Hello everybody and welcome back to another video. Today we're looking at our day 1 and day 2 events. Take a little bit of a peek at day 3 as well, but this is just too variable at the moment and I don't want to go too crazy into that. Really looking at that event as of now. For day 1, you wouldn't look at this and see really anything of interest. Just looks like a few possibly significant events for the United States. Maybe a few dodders that are able to get strong downdrafts. Maybe do this. Get strong enough updrafts to sustain hail. For the most part, we have just three low marginal risks across the United States. What I'm looking at today, though, is actually going to be Canada because that is a little bit more interesting situation. I will be looking at the day 2 for the United States because that has more interest in the Canadian event, but I also want to look into Canadian models. Like this one here, this is for today, which is Saturday, so basically in like a few hours here. This region C is of interest. You can see down here 100 kilometers an hour to 24. That is for wind gusts. So that would be about 60, I think 60 to 75 mile per hour wind gusts is what they're looking at here. They have this tornado symbol. Rain is something that Canada keeps track of as potential severe thunderstorm hazards. We don't do that in the United States, but they do have, good, decent plumes of rain per hour, I'm assuming here. And then 4 centimeters to 6 centimeters hail. I don't think that's really that big. That's 1.5 inches. About 2.5 too. Not huge hail, and I don't think it would warrant any hatched regions like what we have. Yeah, so for hatched regions in the United States, it's 2 inch diameter hail. Well, it does seem possible according to the Canadian Bureau, but it doesn't look to be a huge threat. Really, the issue here is tornadoes and strong winds, and I'll look into that right now. But first, let's look at our whole pattern. We have a pretty nice high pressure ridge kind of dominating the United States for honestly the whole month at this point. We have a very strong low pressure system out here in the west, and maybe a little bit of a low pressure up here, but that's not really anything of interest today. What's going on later tonight? We have stronger belt of enhanced flow over here, stronger belt of enhanced flow here, and a pretty stagnant trough. Here's the rat model for later today. You can see it slowly progressing its way eastward, but not much speed. This is all the way to tomorrow. Let me take my 15Z run so we can go into two. Day 1, just very slow moving trough, and into day 2 here as well. Trough center doesn't really move very much. It was out here near California, now it's here in Idaho, a whole more than 24 hours later. Not too much of interest with that trough. Looking at the 700 millibar level will be probably more interesting, and also 850 millibars as well. We'll stay in this sector for. You can see the one thing I believe that's part of our enhanced flow will be 850. Go here. You can see in our kind of our risk area is right here. So let's go back to the day 1. Right there, kind of the northwest point of North Dakota, northeast point of Montana, and then this more southern region of, I believe this is Alberta, although I might be incorrect. I'm not too good on the counties of Canada, but this region including Regina. This is the Manitoba Canadian look, but I'm pretty sure this is Manitoba. Might be wrong. Don't don't quote me on that. Yeah, Canadian Prairie is a decent area. It's very similar to the Central Plains as well, and that's kind of their tornado region. So our region of interest, as I said, this is going to be right in that right where that bullseye was. The main thing here is there's enough cape to really get these storms going. To me, the most interesting thing looking at this was our HRRR. Regarding cape, we have somewhere around 1,000 to 2,500 kilogram of mean layer cape. Most unstable cape doesn't really look too much more exciting. There's a few little bullseyes here in North Dakota. For the most part, this just might be just a convergence sort of event. Look at mass convergence here. With around 0Z, get this kind of convergence maximum right here in the border we're talking about. Then moving on to the night, actually, you see some STP, significant tornado parameter increase there, kind of in this bullseye triple point region right. 3 cape, we'll check that out. There's not too much 3 cape to be had either, though. Surface vorticity, that's always nice to look at. Same thing, not too much. Maybe a little bit of a surface vorticity, front. That's probably the cold front there. Yeah. Then surface map, of course. I actually forgot to look at good. But See the surface low forming in the overnight hours, probably because of the upper level trough moving Rockies. If you look back at the notice, you see here's our upper level trough, and into those overnight hours, this begins to move off the Rockies. That leads to very quick cyclogenesis. You see right there, you have that 1,004 millibars there, and then very quickly end up with a 9, I believe 900, nearing at 900 trough. It's about right at 1,000. So a little bit under our average of 1013. Well, this looks to be more, more of a wind damage threat with probably maybe threats of embedded tornadoes somewhere in there. Tornadoes definitely aren't really the main threat here. I'm gonna take a sounding. I'm gonna actually use the HRRR to take soundings of where storms might be. Also, we're gonna understand what the storms would look like forming. Right here, 0Z. That looks to be the main storm hour. So remember, you're also in the higher. You're more further west too. So the daylight hours are all the way here to about 2Z. But yeah, dew points as well. Also, forgot to mention all of the surface stuff, but definitely get a lot of dew point injection into here. And then overnight hours when the storms get to form here, they have lots of moisture to work. I will actually take the HRRR and just take their soundings on pivotal weather here. Let's take a sounding right next to this storm. See what that looks like. See that kind of wind. So definitely very high based. I can tell here. This doesn't look the best sounding. I'm going to take ahead of this storm instead. So same thing, better dew points in this sounding for how the whole system looks. But the winds aloft are not very strong. You can see this is in the top right here in the photograph. 6 kilometers up in the atmosphere. The winds are only about 35 knots. I think right in 35 knots right there. Not very strong. There is some shear. You can see that angle is pretty good for like tornado reasons, but other than that, the supercellular profile does not look amazing. And looking at this, very large temperature dew point spread, that would mean hail is more of a factor for these early storms. However, I think that the main concern is in the overnight hours. Once it cools off, still have those dew points. Yeah, you can see the temperature dew point spreads decrease. So also the wind environment looks a lot better in this one as well. From 0 to 1 kilometers, you have a good amount of shear, and then 0 to 3 as well. It's pretty nice shear as well. Or around 30 knots of shear, just because of the fact that we're around 0 here, right around 30, from 0 to 3. But you have to take into account there is this capping that will build back into place. So if storms are able to overcome that capping from, if they're strong enough storms beforehand, they could produce a tornado or two. I think wind is ultimately the main threat here, wind and hail. Especially the stronger storms, and that's a big reason why the marginal risk for the United States is very up north there, because it's more of a Canada event. Yeah, let's look lastly at HREF. I like this ensemble, very useful at times. I'm going to be looking at is probability of rotation, basically. So here, right at storm hour, right at 0Z, you get that 30% bullseye updraft helicity probability, and that'll continue itself as you go on into the evening. However, that would eventually decrease until new storms fire a little bit later. I believe this model does show that. Yeah, that reoccurrence. See if I can scroll down here. Actually, let me try to take a better sector. Here. Here we go. So you can see this northwest part. If those initial storms that begin to fire, and then later on, as it gets cooler, you get another kind of round of stronger convection right here. This is probably, again, due to that stronger forcing aloft. The profile, again, doesn't look amazing. Definitely doesn't look very good. But it's much more supercellular. You have that shear in the lower levels. A little bit strange shear, actually. Very out of the northeast. Weird for this looks. But the temperature dew point spreads along this whole skew T are a lot better than they were in the other soundings that we took. Lastly, also with this reignition, I'm going to go back to the Canada sector now. Actually, I can't really go into Canada itself. We can see from higher up here of the entire United States. Just picture yourself, or just look right here. You see, after that reignition, you do get another 30% bullseye, I believe, or at least it's a widespread 10%. A little bit of a 30% bullseye there again at 12Z. So, overnight hours, that's the main concern, it looks like. That's also the Canadian version of the storms. Its own look for this. So the B region as well. This one doesn't say anything about tornadoes, but the winds are another factor. So the initial storms are the main threat with the overnight storms also posing a wind. So enough about Canada. Now we're looking back into Minnesota, which people would call Canada. We're looking at the 2% tornado wind, 15% wind, and hail slight risk for. So it's a pretty widespread slight risk with wind and hail being the main threats here. A small 2% tornado risk, probably similar to the threat we're seeing tonight with Canada's, kind of the Canadian event. I'll switch my sector there for HR, and I'll also zoom back out with the RAP model. See what we're looking at here. We're going up to 500 millibars, same thing. We just have this big old trough, but this is going a little bit further into the United States at this point. And it also is a lot more negatively tilted, which take into account. However, this is not the main forcing. The main forcing is up here, mostly with this cold front that will be going through. I'll get into that right now. I'll get a better sector. We're currently looking at 700 millibars, and I think our main forcing is going to be this 850 trough going. So here's 850 millibars, and you can see a lot better 850 millibar flow. That lower level jet, kind of increased at this one point here, decreases as you go on, but there's pretty widespread 850 millibar jet, 20 knots, pretty much all around. The 700 millibar level, there's not really short waves that I can see. Earlier on 18Z here, I see a bit of a semblance of a short wave right here, I would say. Otherwise, it's not really the main forcing. We can HRRR, we'll look at where the precipitation starts and kind of work off of that. Not the best to look at, actually. So the HRRR doesn't really show much storm coverage at all for this region, which is interesting to take into account. Not even the overnight hours either. Oh no, sorry, I was looking at the wrong timing. This is our risk time. This is our main risk hour here, Sunday, and the HRRR doesn't really show much happening at all. The NAM might show a little better what could happen. I mean, the HRRR just being less aggressive with it. Kind of get that storm initiation possible after about 2Z, 9 p.m. Central Time here. I have to take a sounding from it. I'll always take sound. See what that looks like. I'm a big fan of soundings as well. They just what I know the best. And again here, more of a Canada looking event, just a bit closeness with the main trough, main surface low, which I believe is way higher up or north. You can see that cold front draped here, so you can kind of see that wind shift, more winds out of northwest here, then more out of south after that cold front. That's the main forcing, but it's not a very strong cold front. It's part of the reason why Canada saw those storms. The Cape here is kind of ridiculous, according to the name and its T. 5,000 Cape is quite a lot, which could very well happen. The shear in lower levels is nice, although very strange profile being shown around 700 millimeters. That doesn't really make sense. Also a bit of a cap as well. That's something else I wanted to look into was the capping invert. Will likely be our main inhibitor for this system. Let's go to the 15Z wrap run. Severe weather. Let's see here. Severe weather and surface-based SIN. Here's our capping inversion. We're gonna look at Sunday. So right here in the mornings, you can definitely see a very, very strong cap in place, kind of in our risk area. And as you move forward, that cap begins to break right around 18Z, likely with all those that strong 850 millibar flow above it. And then once that flow goes away, it's just kind of up to daylight heating to kind of break the cap. And see that cap starts to break in the North Dakota, South Dakota, Minnesota triple point. 17 joules per kilogram is a very weak cap, and storms will likely get through there with just a little bit of forcing. You can also see a little bit of that cap break more Minnesota region, although there is still strong capping at that point. HRRR likely just thinks storms won't get through this cap. NAM NST is probably lenient with the cap and thinking storms will make it through. And then obviously in the overnight hours, that cap begins to build back in. So interesting to see into account there as well. Regarding the tornado bit, I think it's mostly because of the stronger surface low being the forcing here. So I'll go back to the RAP model just so we can see the better surface low. Right at 19Z, 20Z here. Lots of strong surface winds, especially way up north here where the main risk area is for that tornadoes. 14 knots of pretty widespread 14 knots of flow here. And it's pretty warm though, but the dew points are looking pretty nice. So I guess a few of these discrete storms that could form, that's probably the main thing of interest. Look at surface vorticity, see if there's anything to note. Looks like the overnight wind is also possible. So you can see here, cold front is kind of shown by this vorticity signature. Even here, you have winds out of the northwest and more winds out of the south. Here's our cold front, and would likely be the main force for anything else in the hours. But those initial storms, those are what could be supercellular, I believe. It's like right here. Play sounding right here, 21 Z's. That's 4 p.m. Central Time. See what that looks like. Honestly, I'll take one here. Take one in this point right here. So we'll pair the cap breaking around 23Z. I can take a sounding through the vat mile anyway. Here's our sounding. Let's see, that's the one we already took. Here's the most recent sounding. You can still see that capping inversion right here. Still pretty strong, but the winds are a little better for tornadoes. A lot more lower level shear right there. That's more of that updraft helicity question. Here's the rat mile sounding. Same thing. You have that capping inversion that still will need to be broken, but above it, a very unstable atmosphere and a little bit of curvature in the lower photograph. Otherwise, there's not too much else I see with this system. Like, let's see another more Canada-esque event as well. ARRR again, one of our recent ones, doesn't really show anything for those hours. Simulated reflectivity, just not really there much there at all. Maybe some storms will likely fire. I'd be surprised if nothing happens here at all with SBC putting out day 2 outlook, but never can really tell. So for the most part, that's the most of the event. Day 3, it looks to be somewhat similar. Again, I'll look back at the 500 millibar level here. Wouldn't be surprised to see anything too crazy there. Looks like the NAM actually don't get far enough. Rat model. The NAM model basically just shows this trough beginning to finally expel up to the northeast in this region. So South Dakota, yeah, this big old slight risk area. Looks more to be again more of a wind event for these next 3 days. With Cape here is very ridiculous. I'm seeing some huge Cape levels. And I took just a NAM sounding from this thing. Look apocalyptic. Next day as well, lots of Cape. Two soundings, you can kind of see what the environments could look like. This is very unlikely. 7,000 joules per kilogram of Cape here just doesn't seem right at all. And this wind profile is really bad anyway. Storms, the severe storms. And here's another Cape profile. Again, 7,000 joules per kilogram again, which doesn't look very likely. The effective inflow Capes actually look a little more accurate, about 3,500 joules per kilogram and about 1,000 for day 4. So I did forget to mention also there is a day 4 outlook right now. It's just a slight risk, but it is enough confidence for them to put this out. It looks to be more of a wind and hail risk. Or it's about the instability. But given the likelihood for existence of very unstable atmosphere and some shear, that's why they add that slight risk. And they did say damaging wind and hail would be the most primary. So otherwise, I'll look back into the system in a few days, might likely for the day 3 and 4. But for the most part, thank you for watching. I'll see you in the next one, and goodbye.